So it's my honor to introduce our keynote speaker to you, whom we've already experienced, many of us so far. He's been here since yesterday. Patrick Ball. I'm going to read this bio here because there's a lot of information in it. I don't want to forget anything. Patrick Ball has spent more than 28 years conducting quantitative analysis for truth commissions, non-governmental organizations, international criminal tribunals, and the United Nations missions in El Salvador, Ethiopia, Guatemala, Haiti, South Africa, Chad, Sri Lanka, East Timor, Sierra Leone, Kosovo, Liberia, Peru, Colombia, the Democratic Republic of Congo, and Syria. Patrick has provided expert testimony in several high-profile trials, including those of Slobodan Milosevic, the former president of Serbia, and Hissene Habre, the former president of Chad. He founded the Human Rights Data Analysis Group in 1991, where he currently serves as Director of Research. He's received numerous awards and honors, including the Eugene Lawler Award for Humanitarian Contributions within Computer Science and Informatics, and he's been elected a Fellow of the American Statistical Association. He's on the Advisory Council of Security Force Monitor, a project of the Columbia Law School Human Rights Institute. He's a Fellow of the Human Rights Center at Berkeley Law, and the university, and a Research Fellow at Carnegie Mellon Center for Human Rights Science. He got his bachelor's from Columbia and his doctorate from University of Michigan in sociology, yes? And he will tell us about his pioneering work in using data for human rights. A lot of us, we've already experienced his passion on the topic, and it's greatly appreciated, so thank you.
Test. Thank you very much. I'm really glad to be here, and it's been a really exciting and dynamic 24 hours. In fact, it's been so exciting and dynamic just today that I'm flippy-flopping between 3 different examples, and I'm going to put it to a vote. Okay, are you ready to vote? First, the first possibility is a simulation and analysis of the impact on racial disparity of using predictive policing that some colleagues of mine have done, and I can present that. That is example 1. Example 2 is an analysis of the number of police homicides in the United States. What are people's guesses about what fraction of total homicides in the United States are committed by police? Is it in single digits or double digits? So that's example 2. Example 3 would be an unpacking of the evidence that I presented in the Milosevic case in 2003 before the ICTY. So, those in favor of predictive policing? Okay. Those in favor of police homicide estimation? Okay, predictive policing still winning. And those in favor of Milosevic analysis of killing in migration in Kosovo, and predictive policing it is. Okay, well, there it is. I will present that one. It is not actually my work. I did help out. I wrote some of the code. Those of you who were in the session yesterday will be unsurprised by that. But it is work by my colleagues, Dr. Christian Lum and William Isaac. So I've been at this for a long time. And I've done it for a lot of different kinds of partner organizations, groups that are tiny little human rights groups, all the way to very, very large UN missions. The UN mission in the Democratic Republic of the Congo has over 20,000 people there. The mission's budget is almost $2 billion a year, and a key part of their mission is assessing the pattern of conflict-related homicides. How many statisticians and epidemiologists do you think are among that 21,000-person staff? Right? Now, this should be horrifying to you, as it is to me. That how is it that you're supposed to assess a quantitative pattern when you don't hire anyone with a vestige of the skills who are capable of doing that? Okay? Well, that's not purely a UN problem. The UN, like machine learning, takes a small problem and just amplifies it into a large one. So it is not the UN's fault in some narrow sense. Rather, it is the fault of people who think that quantitative evidence falls from the sky and somehow organizes itself by interns who are skillful with Excel. And this is a terrible problem. And it leads to this problem that people who are not statisticians or data scientists think that statistics can say everything. And this is part of what's landed us in this place of post-truth. But post-truth is nothing new for human rights. We have extensive experience that goes back to the dawn of human history, in which people and institutions who commit mass violence nearly always lie about that. They lie about who did it, they lie about why it was done, they lie about why they think the victim somehow deserved this violence. Now, their lies are typically grotesque and easily disproven, but who will disprove them? Who will face those lies to disprove them? And this is what human rights work does. Human rights campaigns are successful because we are persistent, because we speak with the moral authority of the victims, and because we're committed to the truth. We have a phrase that we will speak truth to power. But if that's to work, it should be true, right? It should be true. And if we're going to speak truth to power with statistics, it really needs to be good statistics. And I'm going to talk a little bit today about what I think that means, what it means to speak with good statistics. Now, I want to be clear about a couple things up front. When we're talking about a human rights campaign, the most important thing in a human rights campaign is not the statistics. The most important thing in a human rights campaign is the vindication of the victims. There's the victims' voices. That's the most important thing in the campaign. But we're going to use statistics along the way. They're going to be a footnote. And that footnote has to be right. If we lose a factual challenge against the apologists for mass violence because we didn't do our work right, that's not just personal malpractice. That's betraying the trust that has been placed in us by the victims. And so with that, with all that rather sanctimonious chitter-chat, let's turn to some real work. And I want to talk about the trial of a grave human rights abuser. I'm sorry, I mean this one. The other one's dead. The other one's dead. And I want to talk about what Habre's regime looked like. And I'm going to start with this example because the data was actually very, very, very simple. So I worked on this project starting in 1998 when Human Rights Watch found a giant pile of documents in an abandoned prison. The documents were covered in rat feces and old chicken bones and mixed with trash. But when they sorted through the documents, they discovered the operational records for one of the key secret police prisons during Habre's regime. Okay? So they fished through all of that, and after many, many, many years of pressure, a court was set up in Senegal called the Extraordinary African Chambers. It was set up by the African Union to try President Habre and senior members of his security forces. And the documents that we got were reorganized. The documents Human Rights Watch and their Chadian partners had found were reorganized and incorporated into the Chadian judicial archives. I went to the archive and photocopied 11,000 documents. Or excuse me, I took photographs of 11,000 documents. And I'll show you in a minute why we had to take photos. We couldn't photocopy them. They were crumbling. These were literally carbon copies, by which I mean a piece of paper behind another piece of paper with carbon in between them through in a typewriter that someone hit keys on. That's what I mean by a carbon copy. Right? When you see CC in an email, kids, it means carbon copy. I know that seems kind of weird, but that's what it actually, now I think it means complementary copy, but nonetheless. So we took all these photographs, and when we sorted through all these documents, we found 518 complete daily situation reports from the prison for over a 1,085-day period from 1985 to 1988. And I'll talk a minute about why I think I can interpolate the missing data. This is what a daily situation report looks like. It's moldy, it's crumbling. I've cranked up the saturation and the contrast like crazy in this image so that we can read it. But what's crucial about this particular page from the 11th of August, 1986, is that it starts out with the number of people in detention who are alive in the morning, the number who are alive in the evening, and then a series of ways that that number could have changed. People could have been released, people could have been transferred to another security force, new people could have been brought in, newly arrested people could have been brought in, or of course, some of them could have died. In this case, 5 of them died that day. That day, 5 of them died. And so if we array all of those daily counts in a simple, very skinny little bar graph, we get a series of periods like this, where we have some missing days, okay? But we also have reasonable consistency. We have a moment in which there's an enormous group of new prisoners brought in, and then that number declines over time. And by looking at the daily situation reports, we can estimate the crude mortality rate by day, which looks like this, okay? Where it peaks in this period in 1986, it peaks at 0.6 per people per 100 prisoner, 0.6 people per 100 prisoners per day. That's about 500 times normal adult male mortality in Chad. But let me put it in a slightly more contextually relevant reference. That's me, by the way, according to a Senegalese newspaper artist. I love that. That is my icon on all kinds of my social media now. What's relevant is that that mortality was something like 1.3 to 4.1 times greater than the mortality of US prisoners in Japanese custody in World War II. And the reason that's relevant is that that event, the way US prisoners in Japanese custody were treated, was judged a war crime in the tribunal, Tokyo Tribunal of 1947. It was also substantially worse than the mortality of German prisoners in Soviet custody, also in World War II. Also a fairly severe situation. So I throw this out as my initial example for a couple of reasons. First of all, because we had the data, all right? We don't have to play around with sampling. The perpetrators told us what the numbers were day by day, okay? So we don't have to worry too much. We have to worry about some of those missing days, but I think we can be reasonably confident that missing days would not radically change this conclusion. Second, the methodological tool we use here is one that even many lawyers can follow. It's called division. You guys laugh. But once I was being cross-examined in a case, and the defense attorney said, but isn't it true, senior expert, that the reason more people died in Group A than in Group B is because Group A is bigger? And I said, sure, and that's why I'm presenting these as percentages in which we divide the number who died by the number who were alive. And the guy looked at me blankly and he said, can you explain that in simpler language? So, you see the challenges. Anyway, moving on, this actually worked for these judges because these judges really wanted to know the answer. And my experience in court cases is that when judges want to know the answer, when they're motivated to figure it out, they do just fine. And in this case, they figured it out and they realized that what I was telling them was not by itself evidence that President Habre committed war crimes. What it was is circumstantial evidence that was consistent with the rest of the stories the prosecution was telling. It was a rebuttal of the defense claim that conditions in the prison were no worse than in any other prison, or in fact no worse than in poor parts of Chad. That this was actually quite extraordinary mortality, and mortality that is something they should have considered. Okay, so it had a lot of impact on the trial. Now, this is the easy case. That's why I started with it, because in human rights data collection, we usually don't know what we don't know. Now, this may seem like, you know, a kind of silly Rumsfeldian epistemological rumination, but it's important because if we don't know what we don't know if what we don't know is systematically different from what we do know. Okay? What if we know something because there's some social process that generates information about that thing? And that social process that generates information is absent for all this other thing. Here's the concrete case that in human rights we worry about all the time. In our team, we have a saying that goes, when a lawyer is killed at high noon in a city square, the entire world knows about it before dinner time. But when a peasant is killed 3 days' walk from a road at the dead of night, we're never going to hear about it. We never hear. Okay? Social visibility creates a selection bias that determines what it is that we're able to observe. And because the kind of data we work with is generally reports about human rights, we're going to get stuff that's not randomly sampled from the underlying population. That's almost impossible to do. Instead, we're going to get reports that we can get. And we have to figure out if there's any way that we can account for the stuff we can't get. And I'm going to show you the method we generally use. And I am enormously sensitive that some of my great statistical heroes I've been reading for decades are in this room, and so I will try not to overstate the findings. But nonetheless, we do have a couple of methods that allow us a little bit of insight into some of the unobserved mortality patterns. And let me show you just one of them that is one that worries me a great deal, and this has to do with mortality in Iraq. There's a really good study that's been going on since 2003 called the Iraq Body Count, and it's a terrific index of the world's media. What the Iraq Body Count has done is organize all the press reports they can get their hands on in something like 20 different languages. I think there's over 150 sources that they've been compiling since 2003. And they record every event that results in death in Iraq that's reported in any of those sources. They put the events together and they try to figure out when the events are the same. They deduplicate the events, and then they report a unique deduplicated range of possible deaths for each day. And I looked at that and I said, you know, I think there's a problem with that count. I think there's a bias in it. And we thought about it for a long time, and to their credit, the Iraq Body Count was willing to share some of their data with us. And so what we did is we organized the data in two dimensions. First, by the size of the event. How big an event is it? So this bar represents all the events with 15 or more victims. This bar is events of 6 to 14 victims. This bar here is 2 to 5 victims. And over here we have events with only 1 victim in them. Okay? So far, so good. We understand these are size of victims. And then we shade the bars by how many reports we get of each of those. Okay? So over here, we find that events of 15 or more victims tend to have 15 or more reports. Okay? And actually, almost none, a very tiny fraction of the very large events have a small number of reports, 2. In fact, you have to go down to events of 6 to 14 to find any events that only have 1 report. And in fact, even then, you only have fewer than a fifth of them, or approximately a fifth of them, have only 1 or 2 reports. In fact, still quite a few of them have 15 or more, and you can see that the bulk of them are larger. And as you get to smaller events, you get fewer and fewer reports, so you get to events of size 1, where 3/4 of them have only 1 or 2 reports. Now, the problem of selection bias is the events with 0 reports. Okay? An event with 0 reports is an event you didn't hear about. So, if you look at this and you ask yourself, what size of events are they that have 0 reports? What do you think? Go ahead, yeah, shout it out. 1. Right. Smaller events are more probable to have 0 reports. That is, we're likely to have a lot of unreported small events and very, very few unreported large events. In fact, we've done a little bit of modeling on this. It's actually really hard to do because the assumptions of the models are not at all satisfied. But it seems in our initial estimates that only about 20 to 25% of events of size 1 get reported, but almost all, perhaps all of the events of 15 or greater get reported. So there's a lot of bias in the reporting mechanism that's correlated with the size of the event. Why does this matter? Because these events actually are part of 2 different conflicts. In retrospect, in this sort of, I can almost hopefully say, post-ISIS period, we recognized that that 2 really different things were going on. We had, on the one hand, large events, and large events really were caused by al-Qaeda in Iraq and by coalition collateral damage events. Those were primarily the drivers of very large events. The weapons used were primarily improvised explosive devices and airstrikes or massacres. They were a random selection of the Iraqi population, were their victims, and their goal, in each case, was either destabilization or control, depending on which of the 2 parties it was. But there was a completely different conflict happening at the same time that was largely unobserved, creating small events. And it was committed by Shia militias with firearms, primarily focused on adult men with the goal of ethnic cleansing, driving Sunni Arabs out of Baghdad into the western part of Iraq. Now, when they got to the western part of Iraq, with their families, their careers destroyed, many of their relatives killed, it should be no surprise that they welcomed ISIS as their protectors, should it? Now look, I am not making the claim that bad data analysis led to the rise of ISIS. That would be a little strong. But what I am saying is that we look to data analysis and statistics as a corrective on our prejudices. We look to quantitative analysis to tell us what are we overlooking. We look to the statistics to find the facts, to figure out what's really going on. But when we use really bad data thoughtlessly, we will reinforce our existing prejudices. We will not arrest them. Okay? And so this is the kind of problem we can have. Now this is one of the biggest examples, but pretty much in every conflict I can point to around the world, there's a very, very strong correlation between social visibility and something we're trying to understand about the conflict. And so our understanding of the conflict without some correction on selection bias, our understanding of the conflict will be driven by that selection bias. It will be driven by the same prejudices we went into the analysis with. We'll get graphs that tell us what we want to hear. That's not helpful. Not only is that not helpful, it can be catastrophic. So in this case, we overstated the importance of large events relative to small events, letting naive statistics reinforce our international biases, and failed to tell the right story. So selection bias, really bad. It's a really, really bad problem. Let me tell you a little bit more about it. So in human rights work, what we usually do is we collect a bunch of databases, okay? And these databases are convenience samples, okay? They have no probability foundation. We don't really know why we got that data and we didn't get some other data. That's very, very difficult for us to know. But we can put them together. We can and we do put them together. In fact, most of the work that I do now is in record linkage or database deduplication, where I use models to try to figure out, when I don't have a unique identifier, I just have a bunch of names and dates and locations, when records are co-referent, when they refer to the same person. I spend almost all my time doing this, all my time that isn't fundraising. I'm no different than a faculty person in this sense. And so we'll get a Venn diagram, right? We have three databases, we put them together, and we determine how they intersect with each other. Okay? And we're interested less in the size of the union of the databases than we are in the pattern of intersection, because the pattern of intersection will allow us to make an inference about the size of the universe, including the unobserved. Now, there's a bunch of limitations on this, and I hope to be pushed on those at the end, because I am not unaware of them, but I don't want to clutter the talk with a bunch of those limitations up front. But if we stratify the data, okay, we divide the data, in this case, between perhaps two perpetrators, and we find, once we've combined the databases, that we have approximately the same number of observed deaths between the two, do we conclude that the perpetrators are equally responsible, that they committed equal number of violations? Well, maybe we do and maybe we don't. It depends on how those databases intersect. Because if we look only at the observed data, we could make a big mistake. In Peru, the Truth Commission combined its data in the early 2000s with data from many other governmental sources. And they discovered that, unlike all the previous studies, the Truth Commission found that the guerrillas of Sendero Luminoso had committed about half again more violations than those attributed to the state. And this was a tremendous surprise to the social scientists working in the commission, and indeed to most of the people, the Latin American intellectuals who watch this, because this is completely different than the rest of Latin America. In most of Latin America, the state committed about 30 times more killings than their guerrilla opponents. In El Salvador, in Guatemala, in Argentina, we're talking 30 to 1. Okay? So to find that it's the other way around, it's something like 3 to 2, really is quite striking. It's quite striking. How would you demonstrate such a thing? Well, I'm not going to present the full Peruvian data, because with just a tiny drop of luck, we have a new article on this coming out sometime in the next few months. So I'll just leave that as a teaser for you. And you can be in touch with me if you'd like that article. Instead, I'm going to turn to the prosecution of another war criminal. No, not that one. This one, okay. I know there seems to be a pattern, but I mean this one on the left. This is José Efraín Ríos Montt, who was the dictator of Guatemala and a very, very close associate of the United States between March of 1982 and August of 1983. And during his regime, President Ríos Montt he authorized the army to kill tens of thousands of people. So the question that arises in that, he was accused of at the time, is, does that killing rise to the level of genocide? Now, it turns out genocide is not simply about killing a lot of people. Genocide means killing a lot of some people while not killing people right next to them. It's about focus. It's about the intention to destroy a specific group. Okay? So, to a kind of epidemiological or social science or statistician's brain, you think, perhaps a relative risk would help us here. What was the relative risk of being indigenous in these communities relative to being non-indigenous in those same communities? So I calculated that. It took, off and on 15 years, but fortunately I can put it on one slide. That seems to be how much of our work actually happens in the world. What we found is that there were about 2,147 people killed by the Army who were indigenous, and I'm going to talk in a moment about how I came to that estimate. Out of a population of about 39,000. Now we have that population in the denominator because there was a census done in 1981, in the immediately preceding the genocide. You may think they did a census right before a genocide. This is shockingly common in the history of the sad history of demography. And there are a couple of demographers, Margot Anderson and Bill Seltzer, who've written extensively and I think very movingly about the use of censuses in the commission of mass atrocity. Guatemala is another of these examples. So we know how many people were alive in the moments immediately preceding the killing, and about 5.5% of the people alive at the beginning of this period were dead by the end of it, murdered by the Army. Now, they're non-indigenous neighbors, people of a different ethnicity, but people living in the same villages. Only 41 of a population of approximately 6,000 were killed, so about 0.7%. And the relative risk, of course, is the ratio between those two crude mortality rates, so approximately 8. And the way we read this is that your probability of being killed by the Army in this period was about 8 times greater if you were indigenous relative to being non-indigenous. To put that in context, if you were Tutsi in the prefecture of Kibuye in Rwanda, your relative risk was about 5 relative to being Hutu. If you were Bosnian in Srebrenica, your probability of being killed relative to being Serbian was a little more than 3. So this was a tremendous level of focus by the Guatemalan Army, a discrimination between the indigenous community and the non-indigenous community. But didn't I just say that we don't know what we don't know? I know. Let's do a little algebra. Let's imagine we have a population n that we don't observe. This is called, for the statisticians doing this, is capture, recapture. I'm going to present the simple Lincoln-Peterson estimator. We don't do it this way. We don't even use Bishop Feinberg and Holland anymore. We have lots better methods. I'm happy to go through all that detail. But just for narrative clarity, I'm going to zoom through this and pretend we can do it with 7th grade algebra. OK, thanks. We have a population n, and we don't observe n. We don't know how many indigenous people were killed. What we observe are a couple of samples. We have, in fact, in this case, 4 samples, but I'm going to show the math with 2. We have a sample A and a sample B, and therefore we can say that the probability with which a death in n is observed by A, assuming that A draws randomly from n, is A over n. Okay? And the probability with which a death in n is observed by Project B is, again, B over n. But remember, we have the data sets. We can put them together. We can do all this work to match them. We can determine who is documented in both, and I'll call that M. So the probability of being in both data sets, M, is equal to M over n. But of course, the way I've set this problem up, A and B are independent of each other. So the product of being in both A and, the probability of being in both A and B is equal to the first probability multiplied by the second probability. This is a data science room, so I'm not going to run through all the algebra, but M over n, AB over n, rearrange the terms. That means we can estimate n. Now, we had to make some big assumptions there. And again, I'm going to leave to Q&A, but I would really like to talk about those assumptions. I am not unaware of them. But I want to keep moving through the substantive part of the talk. This is a big deal for human rights work, because if this is true, and it is true to a very crude first approximation, I think, this gives us a way to address observable deaths in n. Now, there are deaths that are not observable. There's nothing we can do about that. And exactly where that probability of observation lies, below which something is effectively non-observable, is a question of very interesting research right now. But observable deaths, which I think pretty much everything in this that we can figure out seem to be, this will give us a pretty good answer. And what that means is that we can go ahead and make an estimate of the total. So here are the categories of deaths in these in the relevant components. The width of the bar is scaled to the number of people in the census, and the height of the dark areas are the observed deaths. The height of the lighter areas indicate the estimated deaths on top of that. And then there's a confidence interval estimated by jackknifing at the top, shown by a little whisker. And essentially, this repeats the conclusion that I showed in the previous graph. The data come from the census of 1981. This is a page from it. One of the only 2 copies of the census in the United States is at Stanford, which was across the street from where my office was at the time. That was very convenient. And we have also then the data from the left-wing NGOs, the CIDH, the Catholic Church, the REMI, the Truth Commission, and the Governmental Program for Compensation for Losses in the War. Each of them had fairly strict requirements for the documentation of a death. Every one of the records in those deaths includes at least one name, one surname, and a date precise to the month, and a location precise at least to the county. So it's pretty good. These are identifiable deaths. And when we integrate the data, we get an intersection pattern that looks like this. And the way we denote each of these cells, these are essentially cells in a cross-tabulation that's 2 by 2 by 2 by 2 of in or out of each of the databases. We read this by saying that the second from the top row, N0001, means that these are records only documented by the National Program for Compensation, but not by any of the other 3 databases. And there's 3,317 in all the periods and 1,021 records in that observation state only in the period April 1982 to 1983. So I took that to court. And in 2013, I explained it to the panel of judges. You'll see me doing algebra there for the judges. As chance should have it, the case was concluded in May of 2013. The judges said, guilty of genocide. You shall spend the rest of your life in jail. That verdict stood for 10 days. Corruption intervened. The Constitutional Court ordered a new trial. The new trial is ongoing. And I testified again in the new trial 3 weeks ago at the beginning of March. While I was in the hallway after testifying, this judge, Judge Yasmin Barrios, who's not the judge in this case, was walking through because it is, after all, the courthouse, and that's where judges hang out. So uncoincidentally enough, you run into judges in the courthouse. And she was like, oh, you're 5.5%. When I did the derivation of the simple two-system estimator that I did for you just then, I remember a light bulb going off over her head. She followed the math. And it's my experience that when people can follow the math and understand what you're explaining to them, they can be very deeply persuaded, so much so that they remember one detail in an incredibly long case 5 years later. So it's worth it. It's worth it to make the effort. So about 2.5 years ago, my colleagues and I were thinking hard about what's happening in the United States. And our whole careers had been spent abroad. And we, thinking about the United States, decided that the violence of United States policing had risen to a level of severity so severe that we could no longer focus our attention only abroad. And we hired a statistician and we devoted 1/3 of our practice to work in the United States. And so I'm going to present one of the pieces of that to you today about predictive policing. And I'm going to talk a little bit about it in the context of these concerns that we have about the non-observability of many cases and the problems of bias in data. So what is predictive policing? What are we doing? Well, what we're going to do, the theory is that we're going to use data collected by the police through the course of their work to learn patterns in the occurrence of crime. That's the theory. But we're not actually going to do that. We're going to use that data to learn patterns. Come on now. There you go. We're going to learn patterns in the data, right? I mean, we're not doing any of the adjustment that I talked about. We're not doing any projection. We're not trying to do any measurement of what's unobserved. We're just finding patterns in the data. So if we just find patterns in the data, what we're doing is using police records to predict patterns in police records. Okay, let's be clear about that. So we're going to use these patterns then to predict the most likely locations or individuals who will commit future crimes? Or are we going to predict where crime will be detected in the future? Okay. This is an enormous distinction. which is typically lost in this discussion, right? We're going to have a discussion about the unfairness of this, and when you get into these debates, you'll find that the technical people involved will inevitably draw you into a very, very technical discussion about what's fair to measure in the data. And I urge you to say, that's not the problem, okay? I'm sure we can produce a fair estimate of where crime will be detected in the future. That's not only not interesting, that may be itself problematic. Because what happens is that additional police will then be dispatched to those locations where crime has been predicted on the theory that they're going to prevent future crime. Okay? But we don't actually know what happens when those police go to those locations. Okay? Well, I'm going to show you, because we did a little simulation using data from Oakland. And, oopsie, I'm not super good at Keynote. Come on, Keynote. Tell me the story. There. That's Oakland. So here's Oakland. And here's some interesting stuff about Oakland. We're going to talk about drug crimes. And I'm not going to talk about drug crimes because drug crimes are either particularly severe or because necessarily a lot of predictive policing is used for drug crimes. However, people who advocate in favor of predictive policing will often tell you, oh, we don't use it for drug crimes. That is not true. Predictive policing is very frequently used for drug crimes, and if people question that, look at the National Institute of Justice, I think it is, has a giant grant that came out, a grant request for proposals about 6 to 8 months ago, and all the big predictive policing vendors bid on it. So trying to predict drug crime. But the reason we use drug crimes is something a little different. And that is because drug crimes, or at least drug possession and drug use, is measured by non-criminal justice methods. Public health people measure drug use all the time. Here's drug use in Oakland. Everybody uses drugs in Oakland, okay? Everybody in Oakland. Now this part, it turns out that's not Oakland. That's why they aren't using drugs there, just because that's not part of Oakland, all right? Everybody in Oakland uses drugs. I can say I live in San Francisco. It's totally different. Okay? Everybody in Oakland uses drugs. So everybody in Oakland gets arrested for drugs, right? No. No. People in this area get arrested for drugs. Okay? Now, Oakland goes up physically here, right? This is where the hills start. Okay? People of color live here. White people, for the most part, live up here. Okay? That's surely a coincidence. Look, here's the problem. We looked at the scientific papers published by Predictive, which I think is one of the best of the predictive policing companies. We re-implemented their algorithm. It's not that complicated. We observed the locations of drug crimes using the Oakland Police public databases. We then trained their model using 6 months of data, which is what they say they did. And then we will predict what locations are likely to contain the most drug crime based on those previous records. We followed as closely as we could the methods that they have published, and so we will now, I'm going to show you, run a little simulation using the data exactly as they claim to use it. Come on, thing. There we go. See the little blinking dots? That's a day by day. You can see the counter running across the top. We've got little dots. That's where it predicts the drug crimes are going to come on that day. Bang, when we hit 6 months, we cross that line. Those are the places that it's going to start predicting after it started training. Now, a couple of interesting things happen here when we do this, okay? What the training does, I'll run it again. Oops. Up. Up. Down. Down. There. Run. There we go. Blinking dots. Okay, so as we're running along here, we come along, and what happens is as soon as we kick in and start telling the algorithm where to go, we get some targeted policing. And where the targeted policing goes is to the non-white, lower-income population. Okay? Bang. This stuff just focuses in on precisely the patterns that are in the existing data. Okay? And so what happens is that you end up targeting primarily African American people because these are the people living primarily in those locations. So that's pretty terrible, and this is another way of of suggesting that. You can see that they're predicting exactly where the drug crime is found, but it's found there because that's where they're looking. So when I look at these predictive policing models, I'm reminded of the old joke. You guys probably know this joke. It's one of my favorites. You know, you're walking home late at night, walking home from a bar, and you see a guy on his hands and knees crawling around on the ground under a streetlight, and you're like, "Hey, man, you all right? Can I help you?" And he's like, "Hey, I lost my keys." And you're like, "Ah, dude, I'll help you find them. Where'd you lose your keys?" And he's like, "Oh, I lost them back in the bar." And you're like, "Well, why are you looking here?" And he says, "Because this is where the light is." Right? That's what predictive policing is doing, right? It's refocusing the light on the data we already had. And it gets worse. Because what if when the police go someplace, they don't just drive around, they actually arrest people, which is kind of their job. And in fact, in many police departments, they're sanctioned if they don't arrest enough people. Well, let's look at what happens if they do that. I'll give you a hint. It's not good. Okay? What happens is we're training the model as before. Train, 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 train. And then, bang, look at the correlation between the low-income areas and the arrest rates. Okay? The feedback mechanism is instantaneous. And if we let this run, it starts going up far faster and faster. It zeroes in on the problem. Machine learning and predictive policing does not simply continue a bad situation, it amplifies a bad situation. It magnifies the bias in the data. That's why it's terrible. Now, smart technologists will tell you there's things they can do. And you will hear next Friday, no doubt, from several of the apologists for this stuff that, oh, well, we have magic technology for that. Okay, A, no, they don't. And B, they wouldn't know if they did. Because part of the problem here is that we don't know what we don't know. If we think we can ameliorate bias, that's because we have a theory about precisely what that bias looks like. Tell me how it is constitutional for me to bring to a decision about people's liberty a set of probabilities which are essentially my assumptions about how the world really works in order to adjust this model. How can that possibly be legitimate? Now you're taking something that's completely arbitrary and imposing it on something that was just unfair. And so mixing something that's completely arbitrary with something unfair leads to something good? No. No. No, we're going to make it worse. We're going to make it worse. And the problem is that, in my team, we sometimes say that what predictive policing is the marriage of selection bias and confirmation bias, and they live happily ever after. Because what happens is that when you put these when you put this stuff together, it tells the police exactly what they thought they were going to do. They're like, you know what, this model is exactly right. That's just what we were going to do. And then they buy it. Okay? And let's quantify it. Okay? City of Los Angeles pays what I estimate to be about 12 art teachers a year for this. It's not a price in dollars. It's a price in what we aren't investing in our communities. Okay? In bad, racist technology that takes away from things that could make things better. Okay? Let's move on. So, because I switched out the example, normally I work on the estimation of total police homicides. The answer is, in fact, 10% of homicides in the United States are committed by police. More dramatically put, 3/4 of homicides in the United States are committed by people who know each other, who are acquaintances in some way. So of the people killed by stranger, 1/3 of them are killed by police. I am not saying those homicides are all unjustified or illegal. Those are questions for lawyers. What I'm saying in terms of the raw numbers, if you were killed by a stranger, by far the most probable stranger to kill you is a police officer. Not a terrorist, not a mass shooter, not a serial killer. It's a police officer. Okay? Now, there may be a police officer's argument that that's somehow legitimate because people are armed dangerously. In my part of the world, we're very concerned about people in their grandmother's backyard armed with cell phones. But let's think more about that. So what's wrong with criminal justice data? Well, the problem is that it tells us about what police, prosecutors, judges, social workers, and parole officers do. It's about the criminal justice system. And it's a good measure of what the criminal justice system does. But it's only incidentally about some crimes and some criminals. People in the US who commit the same crime have wildly different probabilities of arrest that are largely correlated with their race and class. We know this quantitatively from drug possession data, and we know it qualitatively about every other crime. Criminal justice data comes from criminal justice processes. So getting fair data is a problem on the same level of complexity as fixing the criminal justice system, making it fair, okay? Which I'm sure we can all be like, that's not going to happen for a while. So thinking that we're going to data our way out of the injustices in the criminal justice system is staggeringly naive. That's not going to work. It's also not going to work to make the argument that somehow, because a computer model is consistent, that is fairer than an arbitrary set of judges who make all kinds of irrational decisions. Maybe so, but we know how to call out people who make arbitrary decisions. Once we have a black box, we're stuck with it. We're obscured. The whole decision process has been completely obscured. And the way the debate happens then becomes a rarefied debate among elites and experts. So we transform a debate about an unfair judge, which lots of people can participate in, to a very, very complicated debate about a black box model, which is really, really hard to deal with. And that seems to me a terrible trade. Terrible trade. Let's keep in mind at all times that machine learning finds patterns in data. We don't actually know all that much about how to combine a population inference about what's happening in the world with machine learning predictions. I'm not saying this is necessarily impossible. It's possible this might happen. The only solutions, as I said earlier, are these arbitrary probabilities that we use for correction. Those are the only proposals I've seen. But I can imagine a world in which we use some kind of rigorous population inference to correct the data that we use for machine learning. But that's a world that's very far away because there's an awful lot of road bumps between here and there. All those population inferences are going to involve error, and that error will itself propagate through. Now, maybe error is better than bias. These are just decisions that statisticians have to make all the time, but it's not easy, and it's not going to happen soon, and this is by no means ready for deployment in decisions that govern people's liberty. Predictions using criminal justice data invisibly reproduce the bias in policing, in bail decisions, in plea decisions, in sentencing, probation, parole at every stage. We've got people proposing models for every one of those stages. Why? Because vendors will make money on it. Okay? And I plead with you to not have universities make this worse. So don't argue with people proposing these models about their model performance. That's not the question. That's a distraction. That is a distraction from the fundamental injustice in the data production process. Okay? We can argue till we're blue in the face, as ProPublica has argued with North Point about the Compass model in Florida, about its decisions about pretrial release. We can argue for all day long about what the right fairness measure is. There's a whole round, there's a subfield of statistics evolving called the fairness, accountability, and transparency in machine learning that they've now expanded outward, so now it's just FAT star. These are regrettable acronyms deeply, but the FAT star series is an amazing, intellectually stimulating set of conversations. But I don't think that's the core of the problem. The core of the problem is in how we get the data. And until we have a way to fix that, the answer is, what's wrong with criminal justice data? Everything. Found data does not provide a reliable basis for understanding patterns. And I've used a lot of found data over the years. People pretend, and I'm delighted, there were a couple references to this in the earlier sessions today, that people say, well, I just want to let the data speak. And I'm grateful to Chris Anderson for having said something so breathtakingly boneheaded, because it's actually provided us with a straw man to beat against for the last 12 years. Look, the data never speak for itself. Even if you think you're just representing the data, if you're just going to take the data and make a little bar graph out of it, if you're interpreting that data as though it's the world, what you're saying is, hey, the proportions between the two bars in my bar graph, their relative ratio is the same as the relative ratio in the world. Okay? You are assuming a model. You're assuming a model of perfect representation. Even if you think you're just letting the data speak, you're using a model. You're using a grossly naive model that you have no mathematical foundation for. But there's always a model. And you need to think about what that model is and use it self-consciously and figure out, is it right? Is there some really rigorous probability foundation I can put to that model? Sure, you can screw it up, and you'll get a nasty gram from a really good statistician that you admire, and you'll be like, oops, and you can fix it. But the goal is to do the science in the way that the 20th century statistics taught us. Big data does not give us an escape from the problem of sampling. There's three ways to have rigorous statistics and machine learning predictions. You can have all the data. You can get a random sample. Hard. You can do some kind of posterior modeling of the sampling process. Well, a little bit speculative, but that's where I'm stuck. Okay? And you have to introduce a bunch of assumptions. It's not a pretty story. And it's not an easy story to tell a data science program, because how do you get all the stuff you need to get those pieces in place in a short program? I don't envy your professors. That's very, very hard to do. But if you just get a bunch of data and start visualizing, I hope it doesn't matter. Okay, so when we're worrying about algorithms, don't worry about algorithms. It's not the algorithm's fault. Worry about the data. And it's pedantry, I think, if I just say, it's not the algorithm, it's the data plus algorithms equal a model. Okay, that can be pedantry, except that when we say algorithm, we close the debate to almost everybody involved. Hardly anyone even knows what an algorithm is. And so algorithm becomes this magic, scary word that just says, oh, well, you can't know what's going on here. And so we say things like biased algorithm. What we mean is the model is biased. And the model's biased because the data were poor. Now, you may have made really dumb decisions in the algorithm, but I'm going to assume that the algorithm designer was competent. For the most part, the problems are in the data. And by unpacking this and saying it's not a problem with the algorithm, it's a problem with the model. And the model's problem comes from the data. Now we can argue about the data. And lots of people can participate in the argument about whether or not the data came in a representative and fair way from the universe to which we intend to apply the model. So, in real-world social data, there's nearly always a relationship between the observability of the data and the question we're trying to answer. This is a big deal. And we have to figure out something about that in order to build some kind of correction. Biased models, including visualizations, and especially maps. If anyone has a way to represent the uncertainty of estimates using a map, I'd love to see it. I've never seen one. How do you do that? There aren't estimates without uncertainty. So what are we doing just color coding maps? What does that mean? How can we possibly compare spatial locations, estimates across different spatial locations, using a map in a way that conveys the uncertainty of each of the estimates to each other? Let me know. Let me know. And it's extremely difficult in machine learning to assure that training data is representative of selection bias. And I get so kind of all head up about this because I think it matters. It matters because people are going to listen to us and believe us. And if we get it right, well, the bad guys go to prison for the rest of their lives. Okay? I hope you don't hear my critique of police technology as being critical of the police. Most of my career has been supporting law enforcement. Now, the people I'm prosecuting, well, let me tell you who they are. This guy here, his name's Edgar Fernando Garcia. That was his name, anyway. He was a student and labor activist in Guatemala in the 1970s and early 1980s, which was a pretty courageous thing to do in those days at that time. So one day in early February 1984, he left his office and he didn't come home. His wife, Nineth, knew what that meant. Okay? So she started calling around. She called his friends. She called all the police stations. She went to all the police stations. She went to all the army bases around Guatemala City. She called Amnesty. She called all the embassies. She called everybody. In fact, she kept doing that for the next 20 years, looking for her husband. She went to the police. She said, "Did you arrest my husband?" And they're like, "No, I don't know. Maybe the leftists killed him." That's how cynical they were. Okay? The army said, "I've never even heard of this guy. We don't even know who he is." And there it stood. There it stood. Nineth, just tireless, this woman, tireless. She founded what has been for many years one of Guatemala's most important human rights groups, the Mutual Support Group. She continued this work on behalf of herself, looking for her husband, as well as on behalf of thousands of other people in Guatemala who'd lost their family members to disappearance. Now, in 2006, a kind of miracle occurred. And by chance, the Human Rights Ombudsman stumbled upon a warehouse, a giant 4-building warehouse that contained 80 million pages of paper. 80 million pages of paper. And they were like, oh boy. And after they brushed off the rat feces, and they brushed off the dead insects and scraped off the mold and started pulling out the paper, they were like, holy cow, these are the archives of the police that go back to 1884. What are we going to do? People are like, let's call an archivist. Let's call digital preservation experts. Hey, let's call a statistician. So I got to go, and they said, what can we say statistically about violence in Guatemala? I'm like, well, let's say what we can say statistically about these documents. That's the universe we can sample from. So with some advisors from Westat, survey research house outside of Washington, some really amazing survey statisticians, Paul Zadora and Gary Shapiro. We designed a topological sample. And we sampled from the topology of these bags and boxes and bundles of paper. And we sampled iteratively because every few weeks the whole thing had changed as they were cleaning and preserving. So we constantly restructured the frame as the topology of documents changed. And we constantly sampled 3,000 to 4,000 documents at a time, choosing points randomly in space, going to that point, measuring from the ceiling, the wall, and the floor, and finding the point, finding the document closest to that point, pulling it out, coding it, and then putting it back. And we did that for 26,000 documents. The point of that was to be able to characterize the documents in the archive in some kind of rigorous way. And why would we do such a thing? Well, we had many theories, but how it ended up playing out in the first case, because while we were doing that, historians were also just reading the documents for what they actually contained, and they found documents that indicated that the police indeed had arrested Mr. Garcia, tortured him to death, and hidden his body. They found those documents. But the documents were missing dates. Not all of them had a from or a to at the top. These are official memos. And the official memos, the standard pattern of documents flowing through the bureaucracy is they had stamps on them. These are physical pieces of paper that move from office to office. And the way you tell your boss that you've done your job is that on the stamp you initial the part that says, I'm supposed to have read this. Okay? This is old school, folks. So you initial that part and then you pass it to the next person in the chain who's supposed to have read the document and taken perhaps some action on it. So we looked through these and they're missing all sorts of official pieces. And so one of the things we said when they arrested the guys who captured Mr. Garcia, tortured him and hid his body, these two guys, when they were tried, one of my colleagues testified in that trial to say, yeah, you know, the statistical pattern of missing information on these documents in the case that are relevant to the case is identical to the statistical pattern of missingness throughout the rest of the archive. These documents are no different than the rest of the archive. And the judge was like, that's very helpful. That rejects the defense's claim that these documents are somehow weird. You're guilty. And they were like, hey, wait, Your Honor, we were just following orders. And the judge was like, dude, Nuremberg, no. Just following orders. In the United States, we don't say just following orders. We say he was just doing his job. That's the version of that exact logic that we use in the United States when we excuse an atrocity. We say, well, he's just doing his job. Everybody has to do their job. Well, that's the same as saying you were just following orders. And that is not a defense for a grave human rights crime. So they were convicted and sent to jail for 40 years. But when that happened, the judge turned to the prosecutor and said, they said they were following orders. Whose orders? This is the part of my job that I think has been most satisfying of anything I've done. More than testifying against Milosevic, more than testifying against Rios Montt, more than testifying against Hassan Habre, was testifying against this man, Hector Bol de la Cruz. He was the National Police Director from 1981 to 1985. He was the guy who gave these orders. And what I testified to in that case is that the pattern of signatures and seals across all these documents indicated that the documents in this case followed the same pattern through the bureaucracy as the documents in the rest of the archive. Here's how bureaucracies work, folks. People at the top have a strategic vision. They pass it to a planning group. The planning group makes a bunch of plans. They then operationalize those plans. The operational plans become orders. Those are passed down to the actual operational units. The operational units receive the orders. They tell the guys to go out and do their jobs. Guys go out and do their jobs. They come back. They tell them what they've done. Reports are written. Reports go back up the chain, accumulating signatures on the way, and then they land in the archive. They're bureaucracies. And the reason they're bureaucracies is because when you build an institution that can commit enormous violence, you need to keep control of it. Okay? There's an enormous temptation by guys like these to just turn that organization into a mechanism for personal enrichment, for settling their own scores, for doing local extortion. Okay? It's very, very difficult for police forces to prevent their officers from just turning into criminals. It is not an accident that the NYPD often jokingly describes itself as New York's toughest gang. Okay? Now, the way you prevent that is with an awful lot of bureaucratic oversight. And so this bureaucratic oversight demonstrated to us the connection of him to this. Now, we didn't have an order from Colonel Bol de la Cruz directly to these guys to commit these murders. What we had is a bureaucratic practice. And we had documents that fit that bureaucratic practice, and that was my testimony. And so the day after this sentence was was handed down, or the day the sentence was handed down, this little girl in her mother's arms, well, she's a grown-up human rights lawyer in Guatemala now. And here she is being embraced by his mother, her grandmother, because this is what justice means. This is why we need justice. And particularly, this is why we need justice. When the people that we trust to protect us betray that trust and use their power and authority to commit violence against us. That's what human rights stands for. That's why I do my job. I hope you'll join me. Thank you very much for your time.
Thank you. That was awesome. We have time for a few questions. Yes, back there.
Well, it's a very interesting. Okay. It's a very interesting talk. Thank you so much, Mr. Ball. I'm Peruvian, by the way.
Ah, bueno, mucho gusto.
Yeah. I was thinking in terms of the Truth Commission, right? You work with them,
Yes.
you know. So you know probably Professor Carlos Iván de Gregori, who passed away a few times.
Of course, yeah.
A few years ago. And as you know, we had something like we called public audiences, right? I mean, public testimonies.
Yes,
I mean,
most truth commissions have had
yes,
them.
exactly. So how, I mean, since you showed us printed version of these data, which are actually ordered or classified by specific items, right? How can we incorporate data like that, like video
Audiences.
or recording audio or something like that?
I don't actually know. So the question is, a public audience was a kind of a hearing in which victims and in some cases perpetrators were invited to tell their stories as a way to explain to people a kind of narrative reality of how the violence or conflict had occurred. And these have been fairly common in truth commissions since the Haitian Commission in 1995. I have never used the data from the audiences, okay, from the hearings. I've only ever used the testimony data that was given to the commission directly, which I recall in Peru was on the order of 17,000 individual testimonies, and some collective testimonies were given to the data collection teams at the Truth Commission. And I did not work directly with them. I want to give credit to some of my most respected partners I've ever worked with, including David Salmont and Daniel Manrique Vallier from the commission, who were just breathtakingly good scientists, both of them. And it's with Daniel that I'm now writing this new paper on Peru. He's now a statistics professor at Indiana University. After he was so excited by the statistics work we did at the Truth Commission that he went to Carnegie Mellon University in Pittsburgh, got a PhD with Steve Feinberg, and is now a professor of statistics at Indiana. And we're still working on this data. We're still working on this problem. We're still working on capture-recapture estimates in the presence of really severe capture heterogeneity and list dependence. We now have twice as much data as we had for the CVR, so we have much better resolution. It's much less sparse, and I'll hint to you guys the results are the same. So, and we have way better math because Danielle has now spent a decade working on better methods. We do this cool latent class stratification within each stratum so that we get independence model inside each one with a Bayesian estimate on top of it. It's super cool. And there's an R package for people who want to find it. It's called LCMCR, is the R package that Danielle has written. But I don't know how to use the audiencia data. The only way that I would be able to really use it is if we went through the audiencia data, or the hearing data, and extracted each of the individual events. So we could extract the names of each victim and then tie it in the course of the narrative to the time and location and perpetrator of the event. That'd be the only way I'd know how to use it. I'm sure you could do something really cool with natural language processing, and I know there's a small army of historians who've been going over all of those narratives to tell different stories of them. And I think there's a political scientist in Britain named Livia Schubinger who's done really, really good work on this stuff. And there's a historian, I think, or she might be a political scientist at Harvard, and I'm terrible blanking out her name now. who's also done really, really good work on this. Oh my gosh, I can't believe I'm not remembering her name. I plead age. I'm an old man now. But anyway, there's a bunch of people who've done really good work on the qualitative side. I have not. Michelle Levy is another one. She's a political scientist at College of Worcester in Ohio, who's done a lot of work also on the audience data, as well as working with community groups who participated in the audiences to talk about how they experienced them subsequently. So there have been a bunch of them, and I'm sure in Peru there are even more academics doing really good work. I just am not familiar with their work. But if you want, David Solmont, who's at the Pontificate University, he will know all that work. He's been right on top of it. And he's a really, really amazing scientist. So, yeah.
Great talk. Thank you very much. Have you ever come across like falsified data, and
Absolutely.
how do you separate that out from valid?
Well, you can't actually separate it out. What you have to do is figure out, is there some way you can analyze the sensitivity of your result to the presence of falsification? So you have to assume that the data is not all true. I mean, it's not, right? Human beings lie sometimes about everything. And so some of them are lies. So is your result sensitive to the presence of lies? If so, what kind of lies? Are they lies that look like, if you remember that to me, ultimately, the data look like this. So where in this table could I change numbers that will dramatically change the result? Okay? Now you can play with that, right? I can mess around with it, do it randomly or just systematically, perturb it. And if I do so, what happens? And so part of my testimony in this trial in Guatemala is I took a bunch of the cases that are the N0001 cases from the Programa Nacional de Resarcimiento, and I dropped them at random because those are the cells in that singleton that will be driving the estimates upward. Okay? And I did that in a stratified way across the different strata that I was estimating, and I dropped a bunch of them at different levels and showed that the most you could reduce the relative risk between the two populations, even dropping half of those records, was to about 5. Which is still approximately at a Rwandan level of focus. So I felt like, well, this result is pretty robust. But you can't say there aren't lies. There are going to be lies. The question is, does it matter for your substantive result, for your conclusion? So sensitivity analysis.
Let's have one more question, and then we'll move on.
I wonder if you could talk about the differences in which people think about false positives versus false negatives, and how that ties into differences in reactions to things like predictive policing. I'm thinking about the Oakland example, and I imagine that for a lot of people, the idea that some white bad guys are not being caught is acceptable as long as all of the bad guys that are being caught really are bad guys.
Sure.
You understand what I'm saying?
Yeah.
People tend to get less worried about the unfairness of which bad guys get caught, as long as there's a lot of bad guys getting caught. I wondered to what extent you've experienced that, across your work, and how you deal with that from the standpoint of false positives and false negatives.
So I'm not really going to deal in the individual case. I'm going to leave that to lawyers and judges. What I want to talk about is the impact on communities of over and under policing. Okay? Not on the individual perpetrators. Again, social workers, psychologists, police, judges, lawyers, that's their job. I think as statisticians and as sociologists, our job is to think about what happens to a community when it knows it's being surveilled and the police are on every corner, jumping on every tiny nuisance crime all the time. What happens to that community? What damage to our civic fabric is done when they mistrust the police? Okay? What happens? What does over-policing do to our social fabric? My contention is, and this is not based in data, this is based in being an American citizen watching things happen since Ferguson, being a white American citizen trying to figure out my role in it, and looking at things like how African American schools have way more police in them, and police officers deal with things that if I were a high school student, and when I was a high school student, stuff that I did that got me sent to sit in the vice principal's office for half an hour, end up with an arrest, putting people on a track to prison. That's what over-policing means. I believe that violent policing against African Americans is the single biggest factor maintaining institutional racial disparities in our country. So it's not about this perpetrator or that perpetrator. It's about how these communities are suffering as a result of unfair policing practice. That's the problem fundamentally, in my opinion. Okay, a bunch of white people get away with it. Listen, we can sometimes, I sometimes call this the Minnesota paradox. About 10 years ago, in Minnesota, it was made very clear by a series of studies, and there were a series of court orders, that Minnesota was sentencing black defendants to much more severe sentences than white defendants. And Minnesota said, oh yeah, that's terrible, I know, we'll sentence everyone like we're sentencing black people. And so Minnesota is one of the only states in the United States right now with an increasing carceral population. Okay, that is so egregiously wrong. Okay, we should just have been treating everyone like we were treating the white people. That's the way to go. And so I'm not really interested in entering a debate about, you know, is the justice system fair as long as we don't ever put an innocent man in jail? First of all, we put innocent people in jail all the time. But I don't want to enter that debate right now either. Just to say, that's not the question that I'm asking. I'm asking, what are we losing by this incredibly punitive policing approach that we continue to think is the only way we can deal with crime in a situation where we have half the homicides we had when I was in college? What the hell? Okay. Thank you very much.